Well, welcome everybody. Good morning, good afternoon, good evening, depending on which time zone you're in. And this is the second of our three-part webinar series on how to analyze the US Census, the Decennial Census, and the American Community Survey using R with Kyle Walker, who is the master at all of this sort of thing. This is being sponsored by the Social Science Data Analysis Network at the University of Michigan. I'm William Fry, I direct it. And we're here for the second of our three webinars. Today's webinar is going to be analyzing the 2020 Decennial Census with R. Last week, those of you who were here saw that we analyzed the American Community Survey there in the 2023, the most recent American Community Survey with R. And those of you who were here last week know that it was a quite extensive presentation. We had a lot of registrants as we do today. If you missed last week, it's not a problem. You can start from scratch here. We're just going to be learning about the 2020 census. And if you want to learn about what we've done last week, that video will be on in the next day or so. I'll say in a few minutes how you can get access to that, so you can go back and look at that as well. The 2020 census, this is 2025, and you might think, well, that's 5 years ago. Is this old data or something like that? Well, they only take the census once every 10 years, and there's nothing like the census. I mean, it covers everybody. It's not a sample survey. It covers everybody in the United States, all small areas, all different racial and ethnic groups, lots of important data that's used over the course of the whole decade, and it's used as a basis for samples that are done by other groups. So to be able to analyze from the census, understand what's going on from the census is a valuable skill to be able to have. And today we're going to talk about the census, the 2020 census. That the products of the census have continued to evolve and come out. So even though the census was done in 2020, and nothing really came out from the census until 2021. And even last fall, there's a new set of things that came out from the 2020 census. So you really need to stay up to date on all of this and learn how to access this with R, which is what we're going to be doing today. We're so pleased to have our main presenter for this whole series is Kyle Walker, who's a professor and chair of the geography department at Texas Christian University. But more important, he's a national expert on how to analyze census products with R. I mean, there's a lot of folks who know a lot about R, a lot of people who know a lot about the census, but Kyle's a guy that puts them together. He's produced programs and techniques to make it easy for you to download and analyze information from all these census products. But again, today, the 2020 census. I'm going to plug his book again, as I always do, because it's a very valuable tool to have. Analyzing US Census Data, Methods, Maps, and Models in R. You can get this from Amazon. It's not absolutely necessary for you to have to be able to get a lot out of these webinars, but it certainly will help to be around for a reference. So I think it's important for you to keep that in mind. Kyle not only has produced all these programs and things, but for those of you who attended last week, he's just an excellent teacher. And what you'll learn out of the 3 hours today is going to be invaluable for you to have. And again, we're going to have a recording of it. A little bit about the recordings. In another day or so, we're going to have the recording of last week's webinar, the one on the American Community Survey, up on our website, which is ssdan.net, N-E-T. Go to events and then go to webinars, and you'll be able to download that. We also have a YouTube channel where you can get that. So as I say, in the next day or so, you'll be able to get last Wednesday's webinar. At the end of all three webinars, the third one being in 2 weeks from today on mapping and spatial analysis using R with census products, that will also be up. So, about a week or so after these webinars are done, you'll be able to get them on our YouTube channel and on our website. And we will send you an email, let you know when they're up. so that you'll be able to access them. But I'm just giving you a heads up of when you can expect to have that. So all of these webinars are self-contained, all three of them. You don't need to have any of the others to be able to get something out of that webinar. But if you want to, you'll be able to get all of them from our website. So that should be what you can expect. So without any further, and I just want to say a little bit about our project, Social Science Data Analysis Network at the University of Michigan. We've been producing all kinds of ways for teachers and students and researchers to have access to various census products. We've been in business for over 30 years, and we deal with teachers who deal only intro courses that want to put census data in their courses. And then we have webinars like this, which are really very sophisticated, although available and accessible to people at all levels. So you want to see our website, ssdan.net. You can see what we've been doing there for quite a while. But without any further ado, I think I'm going to introduce Kyle. This is going to be a 3-hour webinar, but after each hour, there's going to be a 10-minute break so that you can get some food or take a walk or just relax a little bit. And so we go from noon to 3 p.m. Eastern time, and you can translate that into whatever time zone you're in. So without any further ado, I'm going to introduce Kyle Walker, to talk about the decennial census and analyzing it with R.
All right. Well, thank you so much, Bill, for the generous introduction. And thank you to all of you who have taken, a valuable chunk of time out of your day to learn a little bit about working with census data in R. I have been doing this workshop series for the last 5 years with SSDan and the University of Michigan, and the attendance and participation has grown year over year. Today it looks like we have nearly 300 of you here, and that floors me. So I really do appreciate it. I know how busy you all are. And I am excited to share some of the tools that I have been developing over the past several years with you, and hopefully you'll find them useful in your own work. A couple of things. I'm going to share my screen in just a moment, but I want you to have access to a couple sets of materials. So let's go ahead and pull up my screen here. That should allow you to see the slides. And so the slides for today, they are hosted on my website. And if you look in the chat, I'm going to be pasting links as we go that give you access to a variety of materials that we'll be using today. So if you would like to pull up the slides on your own computer, I am pasting that link into the chat and sending it right now. So if you click that link, you'll be taken to the same slide deck that I am working through today. Sometimes I get a few questions about this. You'll want to use your arrow keys to flip through the slides. So, sometimes attendees have a little bit of trouble working with the slide deck. Just use your arrow keys on your keyboard. Or if you're on a phone or a tablet, you should be able to swipe through the various slides. So those are going to be your slides. Additionally, what we're going to be learning how to do today is use the programming language R to access census data, and that requires code. And I want to share with you where all of the code for today's webinar is hosted. It is in a GitHub repository, which I am linking to and sending to the chat now. And so that link will take you to this page, which is the repository for the workshop. And so you're going to see that there's materials and links to slides for last week's workshop. So if you weren't able to attend our discussion on the 2023 American Community Survey, all those materials are there. Additionally, you can find folders here where you can download the code you need for the workshop. So there are a variety of different ways that you can access that code. The code is all embedded in the slides, and the slides are kind of handy. You can copy paste into R. But I want to give you a sense of various ways that you can access the materials. So you'll notice here the section that says how to get the workshop materials. This workshop ideally is designed for people of all skill levels. There will be some more advanced examples, especially towards the end, but there are some introductory examples, assuming no prior expertise or knowledge in the subject matter. And if you are brand new to working with R or working with census data, you likely don't have R installed. Fortunately, I am using a cloud service by the company Posit called Posit Cloud to host an instance of the workshop. And so if you follow this link, and I'm going to copy that link as well into the chat. So I'm sending that now. If you follow this link, I'm going to open in a new tab here. And what that's going to pull up, we're going to boot up a project. So I already have the project active because it's my account. But what you will see if you boot that up, and in fact, let me actually just show you this. I'm going to go ahead and log out, and I'm going to show you exactly how this works. So we're going to fire that up again, and you're going to see a login screen here. So you'll see that you can log in, you can authenticate with a Google account, a GitHub account, or a Clever account if you have that, or you can simply just put in an email. If you don't have an account, you can click sign up here, and then you can sign up with one of your various accounts or simply with an email address. It's free. All you need to put in is an email and a password and your first and last name, and you can pretty much put in whatever name you want. So there's no um, secret information that you need to put in here. So once you log in, I can click login with Google. I have many different Google accounts, so I'm going to choose this one here, and I'm going to sign in. And what that's going to do is it's going to boot up the project that I've prepared for you. And so it'll take a few moments to deploy the project, but this is a pre-built R environment for you. And so if you don't have R installed, I'm not going to walk you through how to install it today, but you can use this cloud environment to follow along with me. So this is going to boot up. You'll notice it just takes a few moments to boot up. I do want to walk you through how you're going to want to use these materials. So you'll see here, you have now a version of R. You'll notice this flashing temporary copy up here at the top of the screen in red. What you will want to do first, before you do anything else, is click Save a Permanent Copy. And that's going to save a permanent copy, as it suggests, over to your personal account. Now, you have a copy of the workshop materials, both for last week and for this week, in your account. And so if you click here, UMich Workshop 2025, you will see last week's materials and this week's materials here. Some of you who attended last week, you may be asking the question, well, I already booted up a project last week. Will this remember anything that I did? This will be a brand new instance of that. And so you can potentially copy your stuff over, or if you have questions in the Q&A, I could potentially kind of give a little bit of feedback on how to sync them. But what this will do is for those of you who are brand new, you get access to all the materials from last week as well. And so you'll see this Decennial Census folder. That's going to be the materials for today. So if you click there, you'll see the source file for the presentation I'm giving, and also this R file, which is a script that contains all of the code that we'll be using today. So if you click decennialcensuscode.r, it will bring up the code we're using today in a script editor. And so I'm going to be working off of my own version of R installed on my machine. That'll be a little bit easier for you to see. One thing that I like to do, and you'll notice here you have the script editor here. That's where you write your code. And then a console, which is kind of like a terminal or even a calculator where you can type in commands. I like to have the console over on the upper right. So I'm going to click Tools, Global Options, Pane Layout, and then I am going to put the console on the upper right. So this is what my screen will look like. And I'll step you through how to execute commands and all of those things for those of you that are new. If you're a more experienced user, there are two things that you can do. One would be you can clone this repository if you're familiar with Git using this command. And that's going to basically initialize a folder on your machine and bring all of the workshop materials down to your computer. If you already had a repository and pulled and cloned the repository last week, use the command git pull from a terminal while you're inside of the workshop, UMich Workshop 2025 folder. That's going to pull down all the new stuff. So if this is not making sense to you, then probably you're not going to want to use Git. This is for the more experienced users. If you feel like you're in between and you already have R and RStudio installed, but you're unfamiliar or uncomfortable with Git, something that you can do is you can click the folder here in GitHub, find the Decennial Census Code.r script file, and then click this little download button that I've highlighted here with my cursor. That will download the script file to your machine. And it's a self-contained file, so you can just go ahead and open that in R or RStudio or Positron or VS Code or whatever you like to use. So that's our introduction in terms of how we get moving with the materials. I'm going to jump back here to the slides and start stepping through. So, Bill introduced me a little bit. Just to reiterate, I'm a professor of geography at TCU. I also consult widely across a variety of industries in the domain of spatial data science. I have developed a variety of R packages over the years. This includes the Tidy Census package, which you're going to be working with today, the Tigris package, which was really my first package that I developed, and I've been maintaining that for a decade, working with census shapefiles. And my most recent package that I've released is called MapGL, which I'll be highlighting a little bit next in the next workshop, and I'm very excited about that one. Another thing, my book, Bill mentioned, you can find that book on Amazon. It came out in 2023, analyzing US Census data. And additionally, I post on social media fairly frequently about census topics, mapping topics. And so I'm going to go ahead and put into the chat if you would like to give me a follow or connect with me. I post in 3 places and I cross post almost everything. So I post on X, formerly Twitter. I'm putting my link in the chat there. I'm over on LinkedIn. If you prefer that platform, you can connect with me here. And I'm also on Blue Sky. If you don't use Blue Sky, it's kind of a newer social media platform where a lot of, I would say, the academic research and data science communities have migrated. And so there are fairly active discussions around topics like census data there that are probably better than, what you'll see on the other platforms. And so you can certainly give me a follow over there as well. Those are the 3 places I post, and, happy to connect with you and hear how you're using these tools. All right. So last week, just recapping, we covered the 2023 ACS. Today is all about decennial census data, mostly a focus on the 2020 census, that we're going to look at historical data resources as well. We'll take a week off next week, and then in 2 weeks, on the 26th, we'll do mapping and spatial analysis with census data, which is always a lot of fun. And even if you don't use mapping in your job, it's a great way to learn a little bit about how to do it. So, as Bill mentioned, we break this up into 3 sections. For the first hour, because we do this setup and extended intro, we will go all the way until the top of the hour. So that'll be 1 p.m. Eastern. We'll then take a 10-minute break. We'll then go another 50 minutes, take a 10-minute break, and then close out the webinar with 50 minutes. So hour 1, we're just focusing on getting started with 2020 decennial US Census data in R. You'll learn the basics of Tidy Census, how to work with its decennial census interface, and learn a little bit about the data sets available. In hour 2, we're going to focus in on analysis workflows. You're going to learn about a popular data analysis and wrangling framework called the Tidyverse and how to use that to analyze census data. And then in hour three, we're going to cover some more advanced topics. We're going to look at the detailed DHC data files, which give you very fine-grained demographic breakouts that you can't necessarily get anywhere else. And we're going to cover the topic of time series analysis, specifically how you do that in Tidy Census. And then I'll give a nod to the NHGIS project, which allows you to go all the way back to the first census in 1790. So let's go ahead and dive right in and get started with 2020 decennial census data. The last thing that I'll mention before we do dive in, I have the chat up, but importantly, I also have the Q&A up. And so the SSDan team is collecting and monitoring questions, and we'll cover some light Q&A uh, every hour or so. And if there's something particularly that pops out as very relevant, I will answer the question live, but I do have that Q&A up on my other screen. I'm keeping an eye on it. So go ahead and ask away. I won't be able to get to every question. And the questions that we can't answer are going to be debugging and technical questions, because those are often so specific to one software environment or computer. We can't answer those live. So if you're saying, oh, something's not working, unfortunately, we can't answer that. But bigger conceptual questions, those are fantastic, and I'll try to answer as many of those as I can. All right, let's keep jumping through. R in our studio, we talked through all of this already, but R is the programming language and software environment we'll be using today, and we'll be using it inside of the RStudio Integrated Development Environment, or IDE. And there are other IDEs you can use for R. RStudio is fantastic. It's been around for a long time. It's a great place to get started. So let's talk a little bit about the decennial census, especially if you're not as familiar with what it is. As Bill mentioned, the last decennial census that we had was in 2020. And you might say, well, 5-year-old data, why is that significant to me? There are a variety of reasons why that is. The decennial census allows us insights into a variety of topics that we can't necessarily get anywhere else. And so the decennial census is mandated by Article 1, Sections 2 and 9 in the US Constitution. And it's intended to be a complete enumeration or count of the US population. And so it's directed by the United States Census Bureau, part of the US Department of Commerce. And it's conducted every 10 years. It's been conducted every 10 years since 1790. And it's used for a variety of purposes. Most significantly, is constitutionally mandated. It's used for proportional representation in Congress, and in turn for congressional redistricting. So for those of you especially who might be coming and visiting us internationally outside the United States, the United States Congress, specifically the House of Representatives, adheres to proportional representation, which means as the demographics of the US change, we redraw congressional district boundaries every 10 years, sometimes in between the census periods. We do see some redrawing as well if there are court challenges or what have you, but we do a full redraw of the districts every 10 years, and to ensure that people are being represented proportionally. There are a limited set of questions asked about race, ethnicity, age, sex, and housing tenure. So if you attended the webinar last week on the American Community Survey, the ACS is a survey sample of the US population. So it's not a complete count, but it asks a wide range of questions that you'll be very interested in that aren't asked in the decennial census. But the decennial census is significant because it gives you some much more granular insights into these specific questions. And importantly, as opposed to the ACS for small areas, it's not a pooled sample over, say, a 5-year period. It reflects a specific point in time intended to be Census Day, which is April 1st of the decennial census year. So we have a variety of different data sets available in the 2020 census. And the first one that comes out is the PL 94-171 redistricting data file. So I'm sure many of you, especially those of you here in the United States, followed issues around the 2020 census, especially as we were trying to finish it up and collect it in the height of the COVID-19 pandemic. And so some of the data releases were delayed. That said, the first data release is the one that was absolutely essential for doing redistricting, and that's going to be your redistricting data. Your main file that you'll work with, which came out a couple years ago now, is the demographic and housing characteristics, or DHC file. So if you worked with decennial census data prior to 2020, this is going to be analogous to summary file 1 in the 2000 and 2010 censuses. And this is the main file that we'll be working with today. We also have the demographic profile, which gets you pre-tabulated variables, which is handy. If you want to look at percentages, for example, and you don't necessarily know, well, how do I calculate this myself? The demographic profile gives you a lot of percentages pre-calculated. And so that's really handy for getting quick demographic insights. We also have tabulations for the 118th Congress. We're now on the 100, we're now later on. We've seen new redistricting since then, but the 118th Congress was Congress that, again, had all those kind of redistricted areas. And so we have tabulations for that. And then the detailed DHCA file and DHCB files, which give you very detailed racial and ethnic categories and then housing characteristics for those categories. So we've got a bunch of data that you can work with. How you get decennial census data. Data.census.gov is going to be your main point and click data portal for getting these data sets. We're going to be working here with something called the Census API, or Application Programming Interface, which allows developers like all of you, you're using R today, so you are developers, to access these data resources with code, so programmatically. And we do that, however, you don't have to hit the API in its raw form. We do it through Tidy Census. So Tidy Census is an R package that I've been maintaining for the last 8 years, and I first released it in 2017. It's an interface to the Decennial Census, the ACS, the Population Estimates Program, and the Public Use Microdata Series APIs. So it doesn't give you access to all of the data sets that are available from the Census Bureau, but it gives you access to what I believe are the most heavily used ones. And so, again, I first released it in 2017, which is crazy to think it's been around for 8 years. But in those 8 years, it's been downloaded, at least from the POSIT Cranmere, over 600,000 times, potentially many more times than that. And so the usage of Tidy Census has really been fantastic to see the uptake within the community. And so we're going to be working with that today. So some key features in Tidy Census, so why you would want to use it. Well, it wrangles census data internally to work with the tidyverse. And so the tidyverse, and I see Charles, great question. I will be answering that question in just a moment. So I appreciate you being on top of that. It wrangles census data internally to return tidyverse ready format data. So it's called Tidy Census because I wrote Tidy Census to return a format that works well with the tidyverse. And you're going to learn how to use the tidyverse and some of its core functionality in hour 2. It also automatically downloads and merges census geometries, so the tiger line shapefiles for mapping. And if you're following the drama around census data over the past week, those tiger line shapefiles were taken down for 2 days. And that's something that we've been having to deal with. And so last week's workshop, they were actually down. They're back up now, so we can use them. But this was a primary motivation for writing Tidy Census, this idea that it's kind of a pain to go and grab the shape files and grab the data and merge them together. And what if we could just do that in one fell swoop? That's what Tidy Census allows you to do. It also includes a variety of analytic tools that support some common workflows. I'll show you a little bit about that today, and allows you, importantly for me, to request states and counties by name. I can't remember FIPS code. I can remember the FIPS code of my state and my county. Can't remember much more than that. So to get started, if you're using Posit Cloud, these packages are already installed for you. You can run this command. These are the packages that you'll need for today's workshop. And you'll use the install.packages command to accomplish that. Additionally, you can set your Census API key, and this wasn't working great last week. I've heard it's working well now. Um, Basically, you can use many APIs require a key. So you have to get an API key to use the service. The Census API does not require a key. You can use it up to 500 times per day without a key. After that, you'll be blocked unless you have a key. So you may say 500 times a day. That sounds like a lot. I would never do that. You'd be surprised. Power users are frequently going well above that 500 query limit. And so you'll probably want to get a key, follow the instructions here to grab one, and then you can set it in your session with the Census API key function. All right, let's go ahead and get started. So our core function, and for those of you who are new to coding and programming, I'm going to step through just a couple small definitions. A function you can think of as like a mini computer program, and it's a program that takes a whole lot of code that I and my collaborators have written over the years and packages it up into a smaller bit of code. So you can execute many lines of code, in some cases, thousands upon thousands, with just a few lines. So it's a little computer program. And functions include what we call parameters, which are kind of little elements of the function that can vary. You can think of, if you're visiting a website and putting values in a drop-down menu, that's what parameters are. And the values you choose then are what we call arguments. So there are two required arguments in the get decennial function: geography and variables. And I like to hard code the year. 2020 is the default year in get decennial, but I still like to hard code it just to, make sure that I have full reproducibility of my code, especially if there are changes in the future. So what this code does, and we're going to go ahead and execute it in just a moment, is it pulls state level total population data from the 2020 decennial census. So let's jump over here and take a look. Now, how do you execute code in R if you've never worked with this before? There are a couple different ways that you can do that. One is you can highlight a block of code and click this run button. What that will do is it will run the code. It'll send that code, as you can see here. Well, first things first, I need to load tidy census. So I click run, I load tidy census into my environment, and then I can highlight and click this run button, and then it executes this code. The other way to do it, and that's how I'll be doing it today, is prior to a block of code, you can use Control or Command Enter, and it will execute all of the related code. So if I'm using Control Enter or Command Enter on a Mac, you'll notice that given where my cursor was, that code gets executed, and then my cursor advances to the next block of code. And so I had a question about this message, and this message will pop up the first time you use get decennial in any session. Note, 2020 decennial census data use differential privacy, a technique that introduces errors into data to preserve respondent confidentiality. Small counts should be interpreted with caution. We're going to talk about that more in just a little bit. First things first, let's take a look at the data that we get back. So you get here a data structure that has, you can think of it almost like a spreadsheet. It's called a data frame or a tibble. And this output has 4 columns. We get a GeoID, which is the FIPS code or the unique ID for that geography. For states, it's going to be 2 digits. You get a name. That's going to be the name as we commonly understand it. The variable ID, which I'll explain more in just a moment, and then the value. So in the 2020 census, Pennsylvania had about 13 million people. California had about 39.5 million. West Virginia had about 1.8 million, and so on and so forth. And so jumping back here to the slides, we can talk through this a little bit. These are the 4 columns that you get back by default. So let's talk about this warning message a little bit. You see this warning message that pops up the first time you use get decennial in any session. So we're getting data by default from the redistricting data summary file, which is not the main file that you'll typically use, but I do make it the default because it was the only game in town for a couple years from the 2020 census. And I didn't want to break any people's existing code. So I left that as the default. For the DHC file, which you'll typically work with, that's something that we're going to take a look at in just a moment. So it tells us that 2020 decennial census data use differential privacy, a technique that introduces errors into data to preserve respondent confidentiality. And you can read this linked file to learn a little bit more about that. What exactly does that mean? So under US Code Title 13, it is essential that the US Census Bureau keeps our responses private. And if any of you have ever worked with the Census Bureau, done any census trainings, you will know this. They take respondent privacy extremely seriously. And, this a kind of additional push, there was a concern over the past few years at the Census Bureau around the ability of malicious actors to reverse engineer census data and identify individuals. And so what they did was they introduced using kind of noise infusion techniques, using this differential privacy method to uh, basically what you'll get is you'll get consistent housing unit counts and in most cases population unit counts, but in in other cases for small counts, you're going to have some noise infused, so it might not be 100% accurate. And so there's been a whole debate about this. Advocates have argued that differential privacy is necessary to satisfy these Title 13 requirements, but critics have said the data becomes less useful and there's not a huge privacy benefit. Again, the questions, if you're able to reverse engineer me and figure out the census block that I live in, that's typically something that is Googleable for many of us. And you know basically the argument is that the potential harms of what is described or trying to be prevented by differential privacy are dwarfed by the actual harms given the insights that are lost by putting in noise infusion. And so this is kind of an active debate that remains ongoing, but I just feel like it's important for you all to be aware of it because, and we'll talk about this when we're working with various geographies over the course of today's workshop. So census data, you can grab data as variables, but they're also organized into tables, and those tables are referenced by a prefix. So if we want to get table P2, for example, from the redistricting data file, instead of passing a variable ID, we can pass in a table ID. And just to show you how that works, jump back over here. I can run table P2. What it's doing is it pulls down the entire table of variables, and then it gives me all of the variables in the table. And so you might look at this and you say, what's different about what I see here versus what I saw before? Well, here we had 52 total rows. And so what that means is what we get is all the 50 states plus the District of Columbia and Puerto Rico. Those are going to be your core states or state equivalents that we get with get decennial geography equals state. You'll notice here, I now have almost 3,800 rows. So I'm going to open up this table. I'm going to show you a trick here. If you click this environment tab and you click on one of your data sets, it's going to pop it up in our studio, as you see here, with an interactive and sortable data viewer. So if I'm going to sort here on the GeoID column, and you'll notice that now I've pulled this table and I get all of these different variables that are in the table for each state. And so for Alabama in particular here, it looks like I've got 73 different variables in this table. And so we have 73 for every state, and then it repeats in the next state. And we'll talk about data structure in a moment. Importantly, many of you who are new to census data or tidy census are probably thinking, well, how do I know what P2 underscore 002N means? That means nothing to me. And it, frankly, that it shouldn't necessarily mean something to you. I'll show you how to look that up in just a moment. All right, so jumping back here to the slides, again, showing the difference between that table parameter and the variables parameter. So let's talk a little bit about census geography, because we put in this code geography equals state. You can see that here. Well, at what geographies can we get data? There are a variety of different geographies at which the Census Bureau aggregates data. And what you see here is not all of those geographies are in fact encapsulated in this diagram, but many of them are. And so the central spine or axis of this diagram, that's going to be your core census hierarchy. And those are going to be the main geographies that you'll commonly work with when you're analyzing census data. The census block is going to be your smallest geography. And part of the reason that decennial census data are useful is because you can only get block level data from the decennial census. So last week's webinar was on the American Community Survey. You can't get block level data in the ACS, but you can get it from the decennial census. Census blocks are going to be analogous to a city block in an urban area, and they're going to be larger than that geographically in rural areas. Census blocks then nest within block groups, which typically contain maybe around 800 to 1,000 people or so on average, though they can vary in size. Block groups then nest within census tracts, which tend to contain an average of around 4,000 people. Census tracts then nest within counties, and counties are both a census enumeration unit and a legal jurisdiction. And then they nest counties or within states, which go all the way up to the nation. So that's going to be your central spine or axis of that census hierarchy. You then have all of these other types of areas. You have American Indian and Alaska Native areas, Native Hawaiian areas. You have voting districts. You have state legislative districts, urban areas, zip code tabulation areas, which approximate zip codes. And you'll notice that they nest irregularly within parent census units. So for example, state legislative districts and school districts understandably fit neatly within states, but not necessarily within counties. Zip codes don't even fit neatly within states. A handful of zip codes, maybe a few dozen around the US, cross state boundaries. So this gives you a little bit of a sense of those geographies. You may then ask the question, well, how do I get data at different geographies for how do I get data at different geographies in Get Decennial? I want to show you here the tidy census documentation. I'm going to pop that over here and we'll take a look, and I'm going to actually grab that URL as well. And I'm going to paste it in the chat. So if you visit this link, I just pasted to the chat. What you can do here is, as we scroll down, you'll notice here that we have a table of geographies. And so this is how you will format your different geographies. So geography equals state gets you state data. Whereas if I want block data, I have to put in geography equals block. And then you'll notice that the geography, this is what you put in. This is what it means in the definition column. The available by column is important. And I'll show you a little bit more about this in a moment. But different geographies are only available at different aggregation levels. So for counties, you can get counties by state or even counties by county. So if you want data for a specific county, you can do that. But you'll notice that these values are not in bold, which means they're optional. By contrast, census tracts, block groups, and blocks require a state, and census blocks beyond that require a county. Um, and it does sometimes vary from census data product to census data product, but you're safest putting in the county to get your data back, because block level polls by state, uh, which are the availability of which tends to vary somewhat, can be very, very large. And so you can go down here and take a look at how you format that. There are a lot of different ways in which you can aggregate this data. And so jumping back here to the slides, I'm just going to close these out so we can flip around nicely. I want to show you first and foremost, how do you take this information and query by state? So as I mentioned, remembering FIPS codes, that's kind of difficult. I live in Texas. I know that our FIPS code is 48. I don't necessarily have many of the other ones memorized, except I know that Alabama is 01 because it's the first state alphabetically, and Wyoming is 56 because it's the last one. And outside of that, I don't necessarily have them memorized, and I work with census data all of the time. So Tidy Census does that translation for you. So for example, let's say we wanted to get total population. We're going to pull this from the DHC file, but we're going to put in state equals MO. So you could put in state equals Missouri or state equals MO for the postal code, and it's going to work. So I'm grabbing county level population in Missouri. Let's go ahead and run that code over here in our studio. Scroll down. So I'm executing the code. I just got it. And now I have my Missouri population data. So it looks like there are 115 counties in Missouri, and I have the 2020 census population for each of those 115 counties. If I want to go more granular than that, especially for those smaller geographies, I can do that. So in this particular case, I might want to query by state and by county. And so counties are an interesting geography around the US because they're counties and county equivalents. So if any of you are joining from Virginia, for example, Virginia is the hardest state in the country to work with because it has a whole bunch of independent cities, and those change somewhat over time. And so you'll have counties. So, for example, if you're in Virginia, and if you've even visited DC, this may or may not be something you're fully aware of, but certain jurisdictions are counties. So, Arlington is actually a county. Arlington is Arlington County, but Alexandria, right next door, is an independent city, but it's treated as a county equivalent in the census. And so, for example, here, I chose one of the trickiest examples to work with, which is St. Louis, because St. Louis is an independent city in Missouri, but it is also surrounded by a county that shares its name, St. Louis County. So if you put in county equals St. Louis by itself, you'll actually get an error message that says, oh, your query matched both St. Louis City and St. Louis County. But if I refine and specifically say St. Louis City, I can get all of the census blocks and total population for those blocks as enumerated in the 2020 census. And so let's go ahead and try that out. Now, this is going to take a little bit more time to pull, depending on your internet connection, because we're pulling block level data. My internet connection here in my office is very fast. And so fortunately, I can get all of these blocks very quickly. Let's see how many blocks are in St. Louis. It looks like they're around 8,000. And I get population data for each of those 8,000 plus census blocks in the city of St. Louis, Missouri. If you're in a slower internet connection, that may take a little bit more time to uh, pull that through. So I'm getting a lot of really good questions here. I happy to answer that probably right when we start that second hour. So keep asking those questions. That's fantastic. Let's go ahead and keep this moving though. So we put in here county equals St. Louis City. I did get one question asking if we could go over this as well. So we've covered geography. The big question, and frankly, the hardest part of working with census data is figuring out the variable codes. And so I've been throwing out these variable codes for you and asking you to trust me that they mean that total population, but you might be saying, well, what exactly does that mean? How do I find out what variables are in there? Uh, I've included a function in Tidy Census called load variables that tries to make variable lookup easier for you. And so we're going to jump back over here to our studio, and I'm going to uncomment these lines of code, and I'm going to execute them. So I'm calling load variables to pull in all of the variables from the DHC file. And then I'm going to use the view command to bring up this interactive data browser. And you'll notice here that the table is sortable, so I can sort by name, label, or concept if I want, and search my data. And interestingly enough here, what this allows you to do is go through and browse. So you'll see the various tables that are available. And I had a question. I do want to answer that. After viewing the available variables, can you speak to the differences between, for example, variables that start with P versus those that start with H? So you'll notice you'll have some variables here that start with H. If we scroll down, you'll see variables that start with P. You'll also see variables that are, say, HCT. And if we go all the way down here, apologies, you'll see PCT. So what do those mean? Let me go back up to the top. Variables that start with H are housing level variables. So this is a housing level variable. The label is total and the concept is housing units. So that'll tell you the total number of housing units. We then can break this out, in this case by the race of the householder. So you'll see here, this is how you'll read it. H10 underscore 003N refers to the total number of housing units that are owner occupied with a householder who is white alone. That's what that means. So you need to read the label and the concept together to get a full sense of what the variable means. And sometimes I'll get questions about, well, why do I have to put in the variable ID? Because this is going to be the variable ID that you'll put in when you're requesting variables from Tidy Census. I make you look these up on purpose because, as you can see, look how many totals there are in the table. So if I just said, I want the variable total, well, which total is it? There are many, many different totals. And sometimes I've seen in analysis workflows, people pull in variables and they haven't really looked up what the concept is, and they get confused because they're pulling from the wrong concept and they are generating incorrect insights. What do the exclamation marks mean in the labels? Nothing in particular. They're just separators used by census. And so H refers to housing level variables. If you see as we scroll down here, HCT, those are going to be housing level variables that are only available at the census tract level and up, which means you can't get them at the block group or the block level. If it's just H, you can get it all the way down to the block level. Or if it's just P, so P refers to person level variables. So these are all going to be person level variables, focusing on population rather than housing units. PCT, similarly, census tract and up. And so when you're browsing for variables, this can get a little bit tricky, but there are a couple tools that make it handy. If I wanted to look at age, for example, I could type in age, and well, age is pretty common in there. So I've reduced here from 9,000 entries to about 7,300 entries. But I can also click this filter button and I can filter on the label column as well. Like, let's say I put in median to get median age, and now I've filtered all the way down from 9,000 possible variables to just 30, which is a lot easier for me to browse. So mess around with that a little bit. The search box, the filter boxes, that can be pretty helpful. All right. So moving along here, we're going to close out the first hour, kind of just talking through how you specify these various data sets. So the DHC data, sum file equals DHC. The demographic profile, you put in sum file equals DP. For the CD118 files, CD118, and then DD HCA and B files, which I'll show you in the third hour, are specified as shown. In terms of tidy census data structure, now tidy census returns what's called tidy or long form data. So your default data structure is tidy or long form data, which gets you variables stacked by row. And this is the way that I like to work with my data. So I've shown you how this works already. I'm pulling here single year age band data by state. And so what that does, if I pull my single year of age data, I'm going to pull that down. And when I take a look at my data, and you can control click on any object, by the way, or command click to pull it up in the data viewer. I'm going to sort here. I now have single year of age data by sex for every state. So this first row is going to be the total population. The second one's going to be total males. And then now we have single year of age data. So this is 0 to 1, 1 to 2, 2 to 3, 3 to 4, et cetera, by state. And it's stacked so that we have one row per age band rather than one row per state. That said, some analysts prefer what we call wide form data, which spreads the variables across the columns and giving you one row per state in this case and one column per variable. So if we jump back here and take a look at it, I want to show you how that differs. I'm going to run this code. And then we take a look at our data. And you'll notice I now have, I'm going to go ahead and view that data as well, sort in ascending order. We now have one row per state, and then we have 211 columns, one column for each of those variables we've requested. All right, the last thing that I want to show you before we break is a trick, and we're going to go into a variety of other tricks over the course of this webinar. But those variable names, I get it. They can be very hard to remember. And so something that you can do is you can use what's called a named vector. And a vector is an object in R that can contain multiple objects within it, say multiple words or numbers or something like that. And I'll show you how this works. Here's an example where I'm grabbing same-sex, the percentage of households that are married same-sex households or partnered same-sex households by county in the state of Florida. And we can get that from the demographic profile here. And so you'll notice here that I'm specifying a named vector, which is defined with this C function. So I'm saying married equals this census code and partnered equals this census code. And so when I do that, I can run this code through. And instead of having the census variable as my column name, I get the value that I put in myself. So I can remember that more easily. And so this is a handy trick that you can use if you don't want to have those raw census variables in your output. You can customize what you get back. All right, we're right at the top of the hour. So that takes us to the end of part one. So if you want, we're gonna take a 10-minute break, stretch your legs a little bit, and I'm gonna review some of those questions. If you would like to stretch your legs, get a drink of water, go get something to eat, feel free. We're gonna start up again in 10 minutes, so 10 minutes after the hour. If you would like to stick around and do some exercises, I will leave this up. Go ahead and use that load variables command to find a variable that interests you, and then use get decennial, and you can repurpose the code that you've learned in this first hour to fetch that data from the decennial census. All right, I'm going to go dark for 10 minutes and I will see you in just a bit for hour two. All right. Um, Welcome back, everyone. Hopefully, you got a chance to take a little bit of a break and maybe work on some of those exercises. Some great questions that I want to spend some time stepping through. So, Barbara had the question: is there a way to access micro level data? Yes, not for the decennial census, but the micro data is corresponds to the American Community Survey, and the third hour of last week's workshop covered using microdata from the ACS. So when that recording is ready, check it out, or the materials are already available in that GitHub repository in your Posit Cloud, and you can take a look at how to access that micro level data. Some other questions, some really good ones. We've got one about I'm playing around trying to find concept definitions for income and poverty and getting nothing. That's correct. Income, poverty, those topics are not found in the decennial census. Those questions are not asked. They are covered in the American Community Survey. So, again, a plug for going back to last week's materials. You're going to find income and poverty data sets in the ACS. Another question about the 119th Congress, which the 118th Congress is the big redistricting, but we had additional redistricting beyond that. So that is a brand new data set that was released. We got the 2020 census basically a month or so ago, tabulated at the 119th Congress. And so let's give it a shot live. So let's say, for example, we wanted to get data on the 119th Congress for total population. And so I'm going to take this and I am going to do CD top 20. And I'm going to change the sum file to CD 119. That's the code for the 119th Congress. I'm going to try running that through. And you'll notice that unfortunately I get an error message. What this tells you is Tidy Census isn't yet updated for the 119th Congress because that data set is brand new. And we have some safeguards in there to do some restrictions. That said, next release of Tidy Census, we'll go ahead and get that updated. So they roll new stuff out all of the time. You can do the CD 118. You can't do the CD 119 yet, but next release of Tidy Census, we'll get that updated for you and you'll be able to use it. So something that's handy and part of the reason that this exercise is useful, you can see what all of the currently supported summary files are. So I try to keep this as updated as possible for all the new data sets. The most recent ones, something that you can do if you see something you can't currently get, go over to the Tidy Census GitHub repository, file an issue, and I'll go ahead and make those updates. The thing about Tidy Census is, it's interesting. I have a couple collaborators on the project. Something that you also can do is you can, if you're so inclined, go and potentially make those updates yourself and submit a pull request for those of you who are developers. Would love to see more of those. The last question that I'll answer, and then we'll continue to dive in, is, we'll jump back over here. Is there a difference between the PL redistricting data and the DHC on variables found in the former? Why did your first example use the PL data set and your second example use the DHC? Well, I wanted to show you, so to the second question, I wanted to show you the default, which is the PL data set. And again, I'm going to keep that the default for 2020 because I don't want to break anyone's existing code. That said, and this, you have to be aware of this, and this is something that can be a little bit frustrating to work with. If we jump back over here to R and we pull in with load variables. So if I want to do like PL vars, I can do something like load variables 2020 PL. And so those are my PL vars. And then I also have my vars here. That's the DHC. So in the PL, you only get 300 some variables, but something, and this is very important, if you look at what's say in table P2 here in the PL, or even a good example of that is some of these other ones, table P5. So table P5 refers to group quarters population. So if you're in juvenile facilities, correctional facilities, colleges and universities, that kind of thing. So table P5 in the PL file is referring to group quarters population. But if we open up our full variables here, and I'm going to filter for P5, you'll notice that P5 means something entirely different in the DHC file. So depending on which sub file you put in, you might get different results. So you have to be aware of that. So be very deliberate in terms of how you do this. You can't assume that the variable names go back and forth or correspond across different data sets. So it would be nice, I think, from a user experience standpoint, if we just had fully unique, we didn't have duplicated variable IDs across the summary files and they were all distinct across them, but that's not the case. And so this is just something that you need to be very aware of. I do see one other question up there about data from the Federal Statistical Research Data Centers. Uh, I will chat about that briefly if I have time toward the end of the webinar, because that is something that is not going to, it probably would only apply to a small percentage of those of you in attendance today. So I used to have access to one of those data centers. I no longer do, so I can speak to it a little bit. All right, so let's jump down here and get started with part 2. All right, so and we're going to go up until the top of the hour covering analysis workflows with 2020 census data. And so what you see here is a little bit of information about the tidyverse. And the tidyverse includes the most popular R packages in the world. The ggplot2 package, which is part of the tidyverse for visualization, which we covered a little bit in the last webinar, is the most popular R package in the world. The tidyverse includes packages that have been downloaded hundreds upon, hundreds of millions of times. And they're an integrated set of packages that have been primarily developed by the Posit team, formerly known as RStudio, and their chief scientist, Hadley Wickham. And so taking a look at this, kind of continue to move on here and talk a little bit about tidy census and the tidyverse. So census data are commonly used in wide format. We talked about that before, where you have variable names spread across the columns, but tidyverse tools work better with tidy data, so data that are stacked by row that are in long format. And tidy census is designed to return data that's pretty much ready to go for use with tidyverse tools. So I want to show you how to explore your data with tidyverse tools, because there are a lot of really handy tools in there that if you've ever worked with databases in SQL, there are a lot of analogous functions in the tidyverse for working with data. So let's go back to our Missouri population data, and let's say we wanted to find out what are the largest and smallest counties in Missouri by population. A couple tools that we can use include the arrange function, which sorts data based on values in one or more columns, and then the filter function, and that allows you to query your data. Say, I want to get only those populations with, or only those counties with a population of 1 million or more. That's the kind of thing that you can do. So we can go back here and re-download our data. And as we jump back here, we're going to load in tidy census and the tidyverse. And we'll re-download our data just in case you need it again. And so you'll notice when I run the arrange function, I say arrange my Missouri population data by the value column. You'll notice that gives me back the data set in ascending order of population. So Worth County, Missouri, with a little under 2,000 people in 2020, is the smallest county in Missouri by population. If I wanted to see the inverse, I would need to use this desc function for descending order of value. And I run that, I now get all of my counties or county equivalents in Missouri in descending order. So we see St. Louis County, Missouri, slightly over 1 million people is the biggest, followed by Jackson County and then St. Charles County in Missouri. So that gives you a little bit of a sense of how to get that work done. One thing I have one attendee who is running into that exact issue that we just talked about with respect to variables across some summary files. So the error that you're getting where you're trying to pull a variable from the DHC file, remember that get decennial defaults to the PL file, not the DHC file. So the attendee who is trying to get the H10_003N data, add another argument. So do after the 2020, do comma, sum file equals, and then in quotes DHC, matching basically what you see here. Add exactly this code, and that should get your code to work. So again, knowing which summary file you're using ends up being very important. And so just reiterating some of those examples that I showed you. What if you want to ask another question, such as what are the counties with a population below, say, 5,000? In this case, we did a search for below 1,000. We didn't get anything back. We get a table with nothing in it. So we might want to refine our criteria a little bit when we're doing some interactive analysis. But the nice thing about this is, and I'm going to jump back here to the code, I can go through and modify that. So let's try it. How many counties have a population of below 1,000? Unfortunately, 0. Okay. Let me interactively modify this. I'm going to call this below 5,000. Maybe there are some counties below 5,000. How many are there? Okay, there are 7. And so I wanted to show you this because this will often be part of the process. You're not necessarily going to know the answers to your questions beforehand. For example, I've never lived in Missouri. I don't know much about the state. And so I might go in and say, well, I want to know which counties have a population below 1,000. Turns out there aren't any. And so I can't do any analysis with that. But I then can iterate and change this. If I wanted to do 10,000, I would just change the value to 10,000. Those of you who are new to R, you might ask, well, do I need to change this object name? You don't, but it's usually a good idea to make your object names consistent with what it is likely to contain. So I might call this something instead like below 10K, or perhaps even better, I could do this something like county query. And so I know if I'm planning to change this every time, so I'm looking here at those counties with a population under 10,000, I can then go through and interactively explore. And that's what the tidyverse allows you to do. It allows for interactive exploration of your data. And so it looks like there are 29 counties in Missouri with population lower than 10,000. So that's an illustration of the filter and arrange functions. I want to cover another workflow with something called a summary variable. And in many cases, when you're working with census or ACS data, your variables are organized into a table. And the first variable in that table is likely to be a denominator for the others. And so that's one thing that's nice about the tables and how census sets them up. Because in many cases, you'll want census counts, but counts are only so useful when you have the baseline population that varies. For example, let's say I want to pull race and ethnicity by metro area, which is called in practical terms in your census data, core based statistical area. And so those are going to vary pretty significantly in size. So the New York metro area is going to be really, really big. You're going to have other metro areas that are much smaller. And a metro area or a core-based statistical area, for those of you who are less familiar with census nomenclature, you can think of it as you have a principal city, at least one principal city for a metro area with a population of at least 50,000 people, and then the surrounding counties around that. And so there's a parameter in Get Decennial called summary var, which can be used to give you another column that's intended to be used as a denominator. Because if I'm comparing New York City metro and I want to know the percent Hispanic population, or I want to compare the Hispanic population in New York versus the Hispanic population in, I don't know, South Bend, Indiana, the value for New York is always going to be bigger for everything because it's so large. But the actual percentage may be different, may be smaller. And to do that, what you want to do is divide by this summary variable to normalize your data. So I want to show you how to do that. Let's say I'm pulling in race and ethnicity variables from the DHC file. So here I've pulled codes for Hispanic, and then non-Hispanic white, non-Hispanic black, non-Hispanic native, and so on and so forth. I'm pulling this by core-based statistical area. So I can grab that, and I'm grabbing with a summary variable, which is the denominator in that table. And so one attendee mentions any guide for selecting the correct summary var. It really depends on what you're studying. You'll often have multiple options within a table, but let's say you wanted to look at the percent of the total population in this particular case that identifies as a particular race or ethnicity. It's going to be that top variable in that table. So for clarity, let me just jump back here. I think this will be helpful to discuss. If I pull up my variables here, and this is table P5, you'll notice that there are a bunch of different variables that refer to race and ethnicity, or race by ethnicity. So in the decennial census, Hispanic origin is treated as an ethnicity within which there are various races. So you can be Black, not Hispanic identifying, but you can also be Black, Hispanic identifying. And so typically in modern American kind of racial discourse, we separate out white non-Hispanic, Black non-Hispanic, Asian non-Hispanic, Native American non-Hispanic, et cetera, and then Hispanic as its own category that's compared with the others. And so in this particular case, you might say, well, how do I choose what to normalize by? It really depends on what you're looking at. So the total population here, that's going to be your top level variable. That's a good denominator if you're wanting to say what is the percentage Hispanic or non-Hispanic white of the total population. But let's say you're focusing specifically on racial identification within the Hispanic community in the United States. Then your summary variable is likely to be this Hispanic or Latino summary variable. And then the variables you're analyzing will be these subcategories. A related question to summary var work for get ACS as well. It absolutely does. We didn't cover it last week, but it absolutely does work. So jumping back here to the code, let's give it a try. I'm going to define a named vector of race variables, and then I'm going to pull that down for all of the core-based statistical areas in the US. Let's take a look at our data set, and I'm going to pop that up in the data viewer, and you'll notice we have 5,600 metropolitan or micropolitan areas. So a micropolitan area, a metro area requires a city or a core a core area, so to speak, surround a core city of 50,000 people. Micro areas can be smaller than that, but still represent sort of a salient built up area. And I'm going to go ahead and sort this first in by name. And so you hear this here is the Aberdeen, South Dakota micro area. We have race and ethnicity breakdowns. And then we've got all of our other metro and micro areas. So you'll notice here I have for each core-based statistical area, I have all of the categories I've requested. And then the summary value, which refers to that total population value, is repeated for each of those race ethnicity categories. And I mentioned this before, again, if we're trying to make comparisons, say I want to understand, here's the first metro area that shows up is Abilene, Texas, which has a population of 176,579. Well, the largest metro in the US is our Newark, Jersey City, which comes in at slightly over 20 million. So if I'm sorting in descending order based on my value, I'm going to have the biggest metros show up for basically everything. So New York has the largest white population in the country. Why is that? Well, it makes sense. It's the largest metro area in the country. It also has the largest Black population and the second largest Hispanic population and the largest Asian population. So New York's just showing up as the biggest or almost the biggest for everything. But the percentages themselves may vary. It doesn't mean that New York is the widest metro area in the country. We usually would think of proportions or percentages for that type of analysis. So I want to show you how to do that. Because we have this summary variable in hand, we can use tidyverse tools and an analysis pipeline, which I'll explain to you in just a moment, to get that done. So I want to talk this through. The mutate function in dplyr, which is one of the core packages in the tidyverse, we use that to calculate a new column in our data set. And then we can use the select function, which allows you to keep or dismiss columns by name. And then we have this funny looking operator here. So there are two different pipe operators in R. This one is the one that's been around for a long time, and it's percentage sign, and then caret percentage sign. You can read that as the word then. So you're basically saying, make me a new data set called CBSA race percent. And we use our assignment operator here in R. That is starting with my CBSA race data set. So start with that. Then use mutate to calculate a new column called percent, which is defined as 100 times the value column divided by the summary value column. Then use select to retain only the name, variable, and percent columns. Get rid of everything else. So let's go ahead and run that code and see how it works. I'm going to clean up my workspace just a little bit. And so I am going to run that calculation, and then we can take a peek at our data. And in fact, I'm going to just pull this up. So now we notice that the percentages change a lot. And if I sort now in descending order, you'll notice that New York doesn't show up toward the top for any of these because we're much more interested here. We're thinking about the population size relative to the total. And so I can sort on name and I get those percentage breakdowns for each of those metro micro areas. And this ends up being very useful for us to really think through race and ethnicity composition, diversity, what have you, across different regions. Beyond that, we can start thinking about other types of analyses. One of those powerful tools that you can use, and if you come from a SQL or database background, you'll be familiar with this, but one of the most powerful tools that you can use in the tidyverse, and it applies to census data in a lot of instances, is group-wise data analysis. And so, a principle that, Hadley Wickham has really pioneered the popularity of is what we call the split, apply, combine method of data analysis. And this is something that's conceptually simple, but extraordinarily powerful. So what is split, apply, combine? Exactly. It's the idea that you look at your data and you identify salient groups within that data set. And those groups might be anything. So I teach at a university, and when I teach this concept to students, I give them the example of, let's say we're looking at grade point averages by major. So we take all of the students at the university and we identify a group that we want to use for comparison. And so you split that data set by those groups. So for the students, it would be by major. For census data, you can think of all sorts of different categories. Could split by state, could split by the majority population. It's really up to you how you do it. But once you've split your data set into groups, so now think of your data and it's been subdivided up into all of these different groups identified by some common characteristic. We then apply a function to each of those groups. And what does that mean? It means we're performing a calculation separately on each of the groups, like what is the largest group, or what is the smallest, or what is the average, or the median, or some other complicated function that you've defined. But we're applying that to each of the groups. And then when we're done, we bring everything back together and we combine them into a completed analysis data set. And so for my students' example, and this resonates with them, I say, okay, let's split our data by major, take the average of the GPAs of students in each major, and then combine that. And then we can say, in which major do students have the highest GPAs or the lowest GPAs? And ask questions about why that is. Well, are students low performing in these majors, or are the courses harder? So the default tidy format returned by tidy census is designed to do this sort of analysis. And so what you can do is you can use either the function group by, or you can use the dot by, as you can see here, notation directly inside of a function. So you can identify groups within a tidyverse function, or you can explicitly group by. I sometimes like to explicitly use group by because I might want to do multiple group-wise analyses or repurpose some of my code. So in this particular case, we're saying take our data, group by name, which means we're grouping by the name of the metro. So we're looking across metros. And then we're filtering where the percent column is equal to the maximum of the percent column. And you might think conceptually, well, what does that mean? It means I'm retaining only those rows where the value of the percent column is equal to the maximum value for that group, which is basically saying, give me back the maximum percentage for each group, which allows me to see what is the biggest racial or ethnic group in each metro. So let's jump back and try to calculate this. So I'm going to calculate largest group. And you'll notice here, for all of these metros, the largest group is Hispanic. But I'm going to go ahead and bring this up here and sort. And now I can see, okay, so for many of these metros, the largest group is white. For some, it's Hispanic. Here in America's Georgia, that's where we see Black show up first and foremost. And it's not necessarily majority. In this case, it's plurality. And so what this allows me to do is analyze across metros what the largest racial or ethnic group is. And so you'll notice there are only two in the entire United States where the largest group is Asian, and that's going to be San Jose, so Silicon Valley, and Honolulu, Hawaii. Those are the only two where Asian is the largest. Uh, Very few metros and micro areas have the Black population as the largest. Hispanic and white tend to be a lot more common. But this allows me to do that analysis. And Barbara asks, why does the resulting file also contain the variable indicating the racial category? The group is always retained. So when you do this sort of analysis that's group wise, that group is always retained. And this is really important because we didn't retain it, we wouldn't know what these values mean. We could say, okay, for San Jose, the largest group has a percentage of 37%. And in this particular case, what we get here is that value. And so really interesting question by Barbara. I want to go back and kind of define this conceptually because there are some differences in how you specify some of those things. So you're absolutely right. The racial category we haven't defined as the group here. That's because we've made the intentional decision to use this filter function. So the filter function is not going to get rid of any columns. And so all that we're doing is we're grouping by the name, and then we're filtering the data set based on a calculation that's applied to the defined groups. And so what that does is it retains all of the columns in the original data set. If you wanted to only retain the columns that are specified in the group, what you would typically do is use the summarize command. But that doesn't exactly do what we're trying to do here. If you look in my book, especially chapter 3, there are tons of examples of how to do the group by and the summarize type workflows. I think that we're alluding to here. But one of the fun things about working with the tidyverse is you can do so many different types of iterative analyses, over the course that allow you to explore census data in many, many different ways. And in fact, let me show you a great example of that. It's actually the very next example. So if we go here, going to that point, in this case, we retain all of the columns and we can see that. But what if you want to ask, okay, what are the median percentages by group? So in this case, we do group by the group and say, okay, we're going to group by the variable here. So we're grouping by the racial group, but we're throwing out now the counties. And I'm using summarize to say, okay, give me back a new column that says the median percentage is the median of the percent column. And I use this notation na.rm equals true, which means I ignore any missing values. And you'll notice when I specify it this way, it does dismiss the column that wasn't included in the group. And you can group by multiple columns if you want to. But if I jump back here to our studio, I can take a look at this and I get an interesting analysis. So I basically looked across all of the metro areas in the US. And I've asked, among all the metro areas, what is the median percentage of each group? So that 50th percentile. So the median for white is 75.2. The median for Native American is about 0.3%. Hispanic is about 7%. Hawaiian Pacific Islander, 0.3% or 0.03%. Black is about 3.6%, and Asian is about 1%. And so you might say, well, that seems pretty low. It's because if you look at it, again, most Americans live in just a handful of counties. So we have 3,200 plus counties in the US, most of which have fairly small populations. And those rural counties, with the exception of a couple parts of the US, such as South Texas and parts of the rural South, are largely non-Hispanic white in their racial composition. And so if we did a weighted median, so weighting by the population size, maybe you see something different. But in this particular case, that's what we get back. All right. So the next workshop in 2 weeks focuses on spatial data and mapping. And I want to highlight this for you today, though, because I want to show you how to, especially with a lot of geographies, we can explore data the way that we have, but when it comes to smaller geographies like census tracts or block groups or, anything smaller than the county, really, you can't really explore your data without mapping it. And so I want to give you a little bit of an overview on how to map decennial census data, and then we'll do a deep dive in 2 weeks. So one of my favorite features of tidy census is the geometry equals true argument. And it just gets you the geometries that you need. So the outlines of your counties or your census tracts or what have you without much hassle. And I want to show you some examples of how to get this done. So if you specify geometry equals true, that does the hard work for you of acquiring and pre-joining census data. So you don't have to go pull the geographic data and the demographic data and put all that together. Tidy Census handles that for you. And when we're making maps, we just showed a process of identifying a summary variable, calculating percentage. That's a useful thing to know how to do. But oftentimes, you don't necessarily have to go through that. If you look in the demographic profile, there are a lot of pre-tabulated percentages that you can use. So here I'm pulling information from the demographic profile on the percent of the population age 65 and up by census tract in West Virginia. So you'll notice that I pull that data down. And I want to show you what I get back. We're going to talk about the data structure more on the 26th, but we get back what's called a simple features data frame. And let's chat that through. So what we see here is, okay, here's my data. You don't need to worry about all of this just yet. Come back in 2 weeks and I'm going to explain all of this to you. But you can think of this as a geographic census data set. So it has the GeoID, it has the name, the variable, and the value. This is all familiar to us from prior examples in our workshop today. But it also has this geometry column. And without getting too much into the weeds today, you'll notice that it's made up of comma-separated coordinate pairs, a longitude and a latitude. And you can think of it as a child's game of connect the dots. So if you take all of these coordinates in order, and then you connect them, you plot them on a map, and then you connect them in order, that will form the shape of each respective row, which in this case is a census tract. So there are 546 census tracts in West Virginia. I could pull up the data set here in my viewer, and I could sort. Okay, what's the oldest census tract? Looks like census tract 16 in Ohio County, West Virginia. Over a third of the population there is over age 65. Whereas this census tract in Cabell County, West Virginia, only 0.5% is. I'm guessing that might be in and around a college campus, but that's the thing. I look at this and I see the variations, and I can maybe do some analysis on this, but I don't know where any of these places are. And even if you're in West Virginia and you know the counties, are you likely to know where all these census tracts are? Oh, I know exactly where census tract 9705 in Pendleton County, West Virginia is. Only the absolute, maybe the state demographer of West Virginia knows this information, but most of us aren't going to know that. And so if we're doing small area analysis like census tracts or block groups, frankly, we can't get a lot of insight just by looking at the tables of data. We're going to want to put it on a map. And we're going to cover in 2 weeks all sorts of really cool customizable tools for mapping. For today, I just want to show you uh, some basic examples using the ever handy map view package. So what is the map view package? The map view package is a package that brings together all sorts of mapping infrastructure in R to allow you to make maps with a single line of code. It's pretty nice. And so the way that this works, and I'm just going to talk this through with you, is we load in map view and we just say map view my spatial data set, and you get an interactive map of your data. So let's try that out. I'm going to load in map view, and I'm going to call map view WV over 65. And you'll notice in my RStudio viewer, I now have an interactive browsable map, kind of like those of you who work in a GIS would have. And so I can go and I can zoom in and out. Like if we go into Morgantown, which is a college town, I notice that the values in Morgantown for percent over 65 are very, very low. That makes sense. You know, when you're in and around a college campus, you're going to have fairly low values of, people in that particular age bracket. That makes a lot of sense. But this is really handy. Now I can explore all the census tracts in my data. I can click around and I can start to get a little bit more information. That said, we probably want to visualize our data as well. And MapView makes this very straightforward. We can make something called a choropleth or shaded map with the argument z call. And I just specify here z call equals value. And that's going to make me a shaded map where the darker colors represent a lower value and the lighter colors represent a higher value that allows me to look at patterns across the state. So let's go ahead and calculate that over here in RStudio. Now I have my shaded map. So if I zoom in here to Morgantown, I see how young Morgantown is, which makes a ton of sense. Morgantown is home to the University of West Virginia. It's not likely to have huge populations of people age 65 and up. Or as I go to some of these more rural tracts, a little bit further to the south, I have some proportionally older populations, which reflects broader patterns of rural aging that we see across the US. I go into some of the more urban areas and I'm going to see a patchwork. Over here in Huntington, there are going to be some older areas and some younger areas as well. And I am not an expert on West Virginia, so I can't necessarily speak to all of the reasons why this is. But feel free to play around with this. It's really interesting to plug this in for, say, Florida or Arizona or states with large retirement communities. You'll find some census tracts with populations upward of 70 to 80% plus with a population over age 65. So we're going to talk a lot more about map customization in a couple of weeks, but I want to show you some basic examples of how you can do customization. So for example, and you can do things like, and I'm going to jump over to this slide here. You can do things like changing the layer name, changing the colors. And so just jumping back over here, I want to show you how that gets done. I have this code here. And you'll notice that we've got a different color palette. I've named this map intuitively in the legend. And now I have something that's a little bit more custom. And we're providing some information about what that map means. And so a common question that I'll get after this is, okay, well, this is really cool. I would like to share this with, people at my organization or embed this in a website. Those are all really good questions. And so This code will show you here, this little save widget function, that shows you how to save out a map view map. So just to show you how this works, I load the HTML widgets package, which you don't need to know a ton about for today, but that's the underlying package that allows you to do interactive visualization in R. And if I use this save widget function, I assign my map to an object here, and then I save out the map to an HTML file. And let me just show you how that works. I'm going to uncomment this code. I'm going to save out my map here. And now I go to my files and I have this West Virginia over 65 HTML file. I'm going to click on it and choose View in Web Browser. And I'm going to pull that over here. One second, it opened in a separate browser. So we're going to pull that over here. And there is my standalone HTML file that I now have and I can use. You'll notice it's just living as a file on my computer. I could upload this to a web server if I wanted to. I could plug it in as an iframe to my website. I could send it to someone because it's self-contained. It's really, really useful to be able to work with information in that way. All right. So that takes us to the end of the second hour. I want to talk through a couple questions as we close out the hour before we break. And then I'll also have some exercises up here on the board. So if you wanted to get started with some exercises, feel free. Try making an interactive map of a different variable from the demographic profile. So use load variables 2020 and then DP in quotes to look them up. Try for a different state. Again, if you wanted to take a look at where are the retirement communities in Florida, give that a shot. I do want to talk through a couple of these questions, and then we'll take a 10-minute break at the top of the hour. How often do census tract boundaries change? Every 10 years. And that's something that is pretty important to know about. We're going to do a deep dive into that and how you handle that in the February 26th workshop. But this is something that is very important. So with every decennial census, the Census Bureau redraws all of the census tracts. Now, that isn't necessarily 100% true. Many census tracts stay the same, but others are combined or subdivided because census tracts are intended to have on average around 4,000 people. And so I live in North Texas, which is a very fast growing part of the country. And so you'll have, say, rural area on the fringe of a metro that in a 10-year period gets developed, subdivided up, and could go from a population of a couple hundred to a few thousand in a matter of years. And so in that particular case, you're going to want to take that census tract um, that has where to get to 4,000 is going to need to be really big. But let's say your census tract is really big and it goes from 4,000 to 20,000 in 10 years, which isn't uncommon in North Texas. I'm now going to split that census tract maybe into 5 separate census tracts to try to keep that 4,000 threshold, which if you're doing small area time series analysis can get kind of tricky. And so there are a variety of tools and techniques that you can use, some of which are included in Tidy Census. And we're going to cover those in greater detail next week because it is inherently a spatial problem to solve that. I will mention something around time series analysis in hour 3. That's coming up. And so feel free to stay tuned. It may answer also some of your questions. So, beyond that, well, that takes us about to the top of the hour. And so I'm going to go ahead and go dark, keep asking those questions. I'll try to stay on top of them as best as possible. When we come back at 10 minutes after 2 Eastern time, we will jump into some, I think, topics that'll be pretty interesting. We'll look at the detailed data files, and then we'll also explore the question of time series analysis. So I'm going to go ahead and pause here, and I'll see you back in about 10 minutes. All right. Oh, welcome back, everyone. And we are going to get moving here with hour 3 of our webinar on decennial census data. And we're going to dive in on the detailed DHCA data file, as well as time series analysis. These topics are maybe a little bit more niche than the topics that we covered in parts 1 and 2, but I think you'll find them really interesting, and it gives you a sense of the depth of analytical questions that can be answered with tidy census and decennial census data. So we'll go all the way up until the end. I'll maybe try to leave a little time for Q&A, or try to answer, but so keep asking those questions. I won't be able to get to everything, but again, 240 of you are still around 2 hours in, so I really do appreciate you taking the time. All right, so let's talk a little bit about the detailed DHCA data file and what that is. It's a tabulation of 2020 decennial census results for population by sex and age. And then the DHCB data file that followed that gives you housing characteristics for those breakouts. And this can be a little bit tricky to work with and figure out, because these files use something called adaptive design. And so I want to spend a little bit of time talking about some potential workflows. So I know these data files are heavily used by organizations that work with very specific subgroups. For example, tribal organizations that are interested in looking at specific tribal breakouts. You can't get that level of granularity group wise. Typically in ACS, you want to go to the decennial census for that. And I'm going to show you how to do some of that analysis here. So, talking about some limitations, I mentioned the adaptive design of the file. And what that means is that data for different groups and geographies may be found in different tables. And so you can't necessarily assume that you're pulling a specific variable for a group or a geography, that it's going to be available for that combination, which can get a little tricky. There's also considerable sparsity in the data, especially when you're going all the way down, say, to the census tract level. And this is something that can be challenging to deal with, because you're going to pull some data and you're not going to have complete geographic coverage for every group. And, that's due to a variety of things, whether it be confidentiality or differential privacy, or the fact that that group, simply because it's such a small group, is not found in that location. And so, jumping through here, we're going to focus today on the DDHCA file, and you query that file with the argument sum file equals DDHCA and get decennial. And you can use the pop group argument to use this file, and it takes a population group code. And I'm going to show you how to get those codes in just a moment. You can get all groups with the argument pop group equals all. That will pull in all the population groups for you. And then you use the pop group label equals true argument, and that'll give you back the label. So you can look up variables the same way with load variables. I will show you this example in just a little bit. So we can fiddle around with this a little bit. I'm going to jump in here. I have some code that allows us to look at this. I'm going to do here a load variables. Let's see, we'll do DDHCA load variables 2020 DDHCA. And we can take a look at that data set. And so this gives you a little bit of the sense of the adaptive design. And this is something that's kind of tricky. So you have here variables for sex by age, 23 age categories, 9 age categories, and 4 age categories. And as an analyst, you might say, oh, this is great because I get pre-tabulated data, and maybe I'm interested in 18 to 44, and I don't want to calculate that myself, but that's not how this works. So what the adaptive design does is that for some groups at some geographies, you'll be able to get the 4-age category data. For other groups, you'll be able to get the 9-age category data. And then for other groups, typically the largest ones, you'll be able to get the 23. So it really depends on the group size in a given location. And this is something that can feel a little tricky. So if we're looking at DDHCB, we can get a sense of the variables in there as well. And so I'll pull that down, open it up. There really aren't that many variables in there, but it allows you to query for family and non-family households. So we have household type 2 categories, 6 categories, 8 categories. And again, that's going to depend on the population size. So it gives you a sense. You can query by population group, and then you can take a look at household type and structure. So that's what those files will get you. Let's look at our first example here. So we're going to go to the state of Minnesota, and we're going to say, okay, at the state level, I want to get the total population, and I want to get it for all of the groups. So here's total population. I'm using some file equals DDHCA. I'm using population group equals all, and I want to label the population groups so I can see for which population groups I can get data at the state level for Minnesota. And this will give you a little bit of a sense of the level of complexity you can get. You can get very detailed breakdowns working with this data. So let's give it a try. I'm going to pull that data down, and I'm going to open up and browse that data set. And so here we have for Minnesota, we've got European alone, about 3.1 million. Albanian, Alsatian, Basque. So the Basque population of Minnesota, 52. You can really see how granular you get. The Andorran population, we get NA. So no recorded Andorrans or not meeting any sort of reporting threshold here. 2 Faroe Islanders in Minnesota. And we can scroll down and you have a lot of different groups. Now, what's a little tricky about this is you do need to be careful with this because they have alone and then alone or in any combination. And the way that these different groups kind of tabulate and nest within each other is not always straightforward. And so that is something that you want to be careful about. I'm going to continue to scroll down, and here we have very specific African origin breakout. So 4 Minnesotans or Equatorial Guinean alone or in any combination. I'm going to keep scrolling down, and then you really get a sense of the complexity of this with respect to Native American tribes. And this is where a lot of the value is, because this level of granularity that you can get in census data is, frankly, it's not something you're going to find from other resources. And so there are many different Native American tribes that are recorded in the census, most of which are going to be geographically specific. And so you're not necessarily going to find too many of them in every location. But if we scroll down, you'll see in some cases, you will have tribal groups, for example, Chippewa, that have larger populations in the state. And so you can kind of scroll down. Here we have the Leech Lake Band. That's going to be a little bit larger. The Mille Lacs Band, Minnesota Chippewa, those are going to be larger. And feel free to modify those, take a look at a different state. And you can really get a sense, though, you have thousands of different groups that are available, many of which are Native American tribes in this data set. So here we go down, we start to see we had some South American and Central American groups, but there's a pretty significant complexity that you get here. And so I see a question, can I get a map of the percentage of a certain population group? We're going to talk about mapping DDHCA data in just a little bit and some potential caveats when you're working with the data. So let's jump back here to the slides and talk through this a little bit. Understanding what the group codes are, that's something that can be a little bit tricky. So the get pop groups function helps you look this up because there's so many different groups. Because we can do pop group equals all, but you may want to query for a particular group code. So this actually works for summary files 2 and 4 in 2000 and summary file 2 in 2010. I'll show you how to get 2010 and 2000 census data in just a moment. But those are kind of equivalent detailed files for those censuses where you can get these population breakouts. So if I use this get pop groups function, I can jump over to R and try this out. I'm going to do this here. And then I'm going to open up my available groups. And here you have a lookup of codes for the DDHCA file. So if you wanted to query specifically for Bulgarians, you would use the population group code 1015, and so on and so forth. And we have about 3,000 different groups that you can query for in this specific file. All right, now let's chat a little bit more about the complexity of things. So I mentioned already the DDHCA file uses an adaptive design, and that makes certain tables available for specific geographies. I'm going to pop out this image so we can take a look at it. And so you can read through this from the census documentation. It uses an adaptive design to determine the amount of data that detailed regional, racial, and ethnic groups and American Indian and Alaska Native tribes and villages receive based on population thresholds and geography level. That makes things a little bit tricky to work with. So it says, at the nation and state levels, detailed and regional groups receive a total population count table, and groups meeting a minimum threshold also receive a sex by age table. So you can't necessarily even get sex by age for every group for every location. For sub-state geographies, we can go down to the census tract. We use population thresholds to determine eligibility for those tables. So you can see here, you have detailed groups and you have regional groups. And so the detailed groups, those are going to be, your Native American tribes. Your regional groups, that's going to be something, referring to a region of the world. And say you want to get the 23 category, sex by age for a sub-state area for one of those Native American tribes. You're only going to be able to do that for sub-state geographies if there are at least 20,000 people in that group. And so that is a fairly difficult threshold to meet. So you're not going to see that as much. Much more commonly, you're going to be in this 4 category or even potentially kind of total count only range. And so understanding how the adaptive design works with respect to pulling data, that's something that can be difficult. And when I was first designing the interface to the detailed files in Tidy Census, I struggled with this because I didn't fully understand exactly how you could help people determine what was happening or what was available in the data sets. And so when we think about this, I'm going to show you here, we're going to call some code here that is designed specifically to fail. So we're going to pull, I'm going to do this in our studio. So we look at our available groups. I'm pulling for group 1325 in Hennepin County, Minnesota. And so 1325, we'll scroll down and see what that is. You'll notice here it's Somali alone or in any combination. So I did my grad studies at the University of Minnesota, and there is a very large Somali population in Minneapolis that's really centered very near to the university. And so they're an ever-present, population within Minneapolis. And so you might be very interested in using the detailed data files to really drill down and say, okay, what's the geography of, what are the dimensions of the Somali population in Minneapolis? So I could potentially try to pull this variable and see what I get. So I am going to try to run this through, and I get this error. And it says, okay, I got an error. And the request returned no content from the API. This was where I was seeing some difficulties. Basically, the API was returning a no content error. It wasn't telling me why my query failed. And so I've built this into Tidy Census to help you with an informative error message. And so um, the request returned no content for the API. It tells you about the adaptive design. It gives you a link to some technical documentation. And then it says, use the function check DDHCA groups to see if your data is available. Okay, um, that's helpful. Apparently there's a function in Tidy Census in which we can go and see if our data is available. And so let's look at that here. This check DDHCA groups allows you to see which tables you can use for the data that you want. And so if I go in and say, okay, I'm looking at the county level for population group 1325 for state equals Minnesota and county equals Hennepin, let's take a look and see what we can get. And we'll try that out here. And it's going to iterate through and check your table availability. So tables T01001 and T02003, those are the ones that I can pull. So if I look here, it looks like I can get, because the population is large enough, the 23 age category band. I tried to pull from the 4 age category band. And you might say, well, that seems counterintuitive. If I can get the 23 age categories, why can't I get the 4 age categories? You can't. You can only get one of the three. You can get the 4, 9, or the 23. Given that the Somali population is so large in Minneapolis and Hennepin County, Minnesota, that's that's allows you to get the more granular age categories. But if you want to tabulate that down, you're going to need to do that yourself. So that gives us some information about what we can do. And then we can start pulling our data accordingly. I've mentioned data sparsity in this data set, and that raises a question, should you make maps with it? We're focusing more on mapping next week or in the next webinar in 2 weeks. But it's a great question. I'm not personally a fan of mapping geographically sparse data. And any of you who attended the webinar last week, I talked about this a little bit with reference to the 1-year American Community Survey. So if you didn't attend last week, I would strongly encourage you, when the video is available, go back through the video from last week and go back through the materials which are available. There are 2 versions of the American Community Survey, which is going to be your annual survey that gets you much more detailed demographic information, income, education, occupation, those sorts of things. The 1-year American Community Survey data, as I explained last week, only reports on population locations of population threshold of 65,000 and up. And so I showed an example in the slides of a map for the state of Texas, where we were only returning counties in Texas with a population of 65,000 and greater, which was basically metropolitan counties. So Austin, San Antonio, Dallas, Fort Worth, Houston. It wasn't showing much else around rural Texas. And I critiqued that. I said, well, you shouldn't really do this because you're not you're not really showing patterns all that well. I say I'm not personally a fan of mapping data that are geographically sparse, but I think it's okay if you think through the data limitations. So if you ask yourself the question, okay, what are the limitations in my data and how can I still communicate effectively? So let's spend a little bit of time talking this through. So here's an example where we're saying, okay, I want to know where the Somali population lives in Minneapolis by census tract, which is a fair question to want to know about because we know that you have a population that is geographically concentrated in particular locations. Making a map of that makes a lot of sense. So I'm specifying here geometry equals true and get decennial, so I can pull that census tract geometry along with it, and I'm functionally maintaining the rest of the code. So let's go ahead and pull that data. I'm going to go ahead and run that through. I got the data, and now I can use map view to make a map of it. Let's see what I get. I get a map, but I get geographical sparsity. And so you can kind of see, and I'll outline this for you. Hennepin County is the county in which the city of Minneapolis is located. The boundaries of the county, you can see they follow here, they go up here, and then they follow the river here, all the way out here. And then you can, when it stops following the river, you can see that dashed line here. That's going to be Hennepin County. So big chunks of the more suburban, exurban parts of the county, we don't get data back. So we have geographically sparse data. And even parts of the city of Minneapolis proper, say here and here and here, we don't get any data back either. If I zoom in, so for example, when I was a student at the University of Minnesota, you can kind of see where the university is right over here. My office was right over here. And so the most prominent Somali population was located right here in the Cedar Riverside part of Minneapolis. And you can see that there's around 2,700 uh, people who identified Somali or alone in any combination, a very large population living there. And then some other parts of the city as well, where you have fairly large Somali populations, say parts of the near north side, parts of the Phillips neighborhood in South Minneapolis. But then other parts of the city, you can see here around downtown, around some of the lakes in Southwest Minneapolis, you're not getting any data back. I can't even click on anything because the census tracts aren't returned. This is because there's no data coming back from the API for those tracts. And so this raises an interesting question. I could conceivably hand this map off to someone, but I personally wouldn't do that. And the reason why is because I am then making an assumption that my audience understands what these gaps are. And they're not necessarily going to, because census tracts, while intuitive to those of us who work in data with census data regularly, they're not necessarily intuitive to everyone else. And so they may see these gaps and they won't necessarily know what to think of it. But there are alternative ways of mapping your data that potentially are more appropriate for data sparsity like this. So let me show you an example. And this is a little bit more advanced, and we'll be covering some of these topics next week, or I'm sorry, in 2 weeks. But I want to give you a preview here because I think it's a useful thing to know about. So a choropleth map arguably doesn't work great. I've made some arguments why that's the case. But other map types might be appropriate. So we're going to learn about map types in 2 weeks. But other map types that don't require, say, a tessellation of census tracts might work. Something that I like for geographically sparse data is what's called a dot density map, which instead of showing the census tracts themselves, you scatter dots proportional to, say, a population size within those tracts. And then you can use heuristics in your data to account for the data sparsity. So there's a function in tidy census called as.density, which we'll do a deeper dive into in 2 weeks. But it allows you to specify the number of people that each dot represents. So instead of, say, that's track that 2,700 self-identifying Somalis there, you could change that into a bunch of scattered dots, each of which represents a given number of people. And then you can represent data suppressed areas as 0 in not just a confident way, but in a actually visually accurate way. So let's talk this through. So data suppression in the DDHC is going to happen here, where there are fewer than 25 Somalis in a given census tract. And so if there are fewer than 25 in a census tract, that area is not going to show up. And so in this particular case, what we can do is we can use this add.density function to say, okay, take my Hennepin Somali data set, and using the value column, generate scattered dots within each census tract, where each dot should represent approximately, it won't be perfect, because we can't have fractions of dots, but each dot should represent around 25 Somalis in the census. And then I can use map view to make a map. And so I'm going to map that out. And let's go ahead and try that ourselves. First, I generate the dots. Doesn't take too long to do that. And then I make the map. And so now we have a dot density map where, because, and we specify in the legend, each dot represents at least 25 people, it's okay that areas are left out, because what that's saying is, well, there are fewer than 25 people in that area. And so in areas like the Cedar Riverside part of Minneapolis, near where my office was when I was in grad school, you see a whole lot of dots representing a clustering or a scattering of dots that, shows a greater density of that population. The density is less in North and South Minneapolis, but it's present. And then in other parts of Minneapolis, like Southwest Minneapolis, we see a lot of data sparsity or nothing, but that's okay, because that now is represented in an accurate way. And this is something that then can be intuitive. Oh, okay, each dot is about 25 people. I can kind of see where those concentrations are, and I can safely assume that out here, they're just a handful. And so Ralph has a good question and is potentially talking about a dot over Breck School in Minneapolis. So the dots within each census tract are randomly placed. So basically, you take each census tract and then you scatter dots within each tract, such that it's just randomly placed. Something that this occasionally leads to is the dots in water phenomenon, where here's a dot that shows up in the Mississippi River. And you might say, well, that's not ideal. There is an argument, and this is getting a little bit into the weeds. So here we have some dots in the water. And it depends. You want to think about who you're presenting to when you're dealing with this, because if you're presenting to a very geographically literate audience, they will look at this and they will understand that the dots are randomly placed. But if you're presenting to, say, a general audience that doesn't necessarily know what a dot density map means, they will say, well, why is there a dot in that lake? Your data must be wrong. I can't trust you. And this is something that I've heard personally when I have released maps and people see stuff like that and they don't understand, which why would they? This is something that's fairly niche. There is an argument in add dot density that as dot density, and I'm going to pull up the help documentation for that. That's called erase water. And if you set erase water to true, what it does is it actually runs through a workflow to remove water areas from your census tracts before placing the dots. And then that avoids this dots and water phenomenon, which is pretty handy. I'll probably go into that in more depth in 2 weeks because it's a little bit beyond the scope of today's workshop, but I did want to mention that given the question. All right. We're getting toward the end of the workshop, so I want to cover the last topic for today, which is time series analysis. And I get a lot of questions about this. Well, I'm really interested in understanding change over time. And census data are really good for change over time analysis because they represent a specific point in time. So as opposed to the American Community Survey, in which your small areas are going to be represented in the 5-year ACS, which is a pooled sample of 5 years of ACS data so that we get enough statistical confidence to report. The decennial census is a complete count. And so it doesn't necessarily get you temporal recency, unfortunately, but it gets you temporal granularity. So you say this was the tabulation at this point in time. So how do you do time series analysis? So you might ask the question, which areas have experienced the most population growth and which have experienced the steepest declines? In tidy census, you can access the 2000 and 2010 census data. Be aware, variable IDs differ and summary files also differ. So you have to spend some time figuring that out. So let's talk about this. Let's ask this question. What are the fastest growing areas between 2010 and 2020? And what are the slowest growing? So let's grab some data from the 2010 census. We use get decennial. Geography equals county is the name, though our variables is going to be different. So we're doing variables equals, and this corresponds to what we've looked up in, say, load variables for the 2010 census. The year is 2010, and our summary file is SF1. So prior to 2020, we had summary files that were labeled summary file 1, summary file 3. In the 2000 census, that was before we had the American Community Survey, summary file 3 was based on something called the census long form, which was sent to about 1 in 6 households in the United States. And that asked all the questions that we now ask in the ACS. So summary file 3 does not exist for the 2010 census, nor the 2020 census. All of that's now handled in the American Community Survey. So I pull this data down, and let's go ahead and take a look at it. So county population 10, we pull down, and we take a look at our data. And so now we have county populations in 2010. So we have the same structure, GeoID, name, variable, and value. And we can take a look at our data as well in the data browser. We can sort our data if we want. The largest county in 2010 was Los Angeles County with about 9.8 million people. The smallest was Loving County, Texas, with 82. So a pretty wide range. And so what we need to figure out now is how to do some matching. We're going to need to match this data with some 2020 data and then calculate some change over time. First things first, let's clean up our data a little bit before joining, because as we notice here, we have a value column, but we will also get a value column when we pull from 2020. And so we want to make sure that those are different. And so there are ways to do that as you merge data together. We're going to do a little pre-processing first, just to be very deliberate about it. So what I'm doing here is I'm only selecting the GeoID column because that's what we're going to merge on. And then I'm renaming the value column to value 10. So let's go ahead and use our tidyverse tools to do that. And this is now what our data looks like for 2010. We have a GeoID. It's okay that we lost the name of the county because we're just going to bring that in from 2020. And then we are also going to bring in our 2010 population. So let's see how we do that. We're going to grab our 2020 data and do the same sort of cleanup, but we're going to retain the GeoID and the name columns. And then we're going to, once we have that data, use this left join function, which merges all of the data from our 2010 data set to our 2020 data set on one or more common column values. In this case, we're using that FIPS code, which is contained in your GeoID column. So from here, we can make that calculation, run our join, and then take a look at our join data. So here now I have all of the counties in the United States, all 3,221 counties and county equivalents. And I can look at their value in 2020 and 2010. So let me sort in ascending order here. Here's Watauga County, Alabama. Its 2020 value was about 58,800. Looks like it grew by a few thousand since 2010. If we look at our biggest counties in the US, for example, Los Angeles County grew slightly. Now, it's been declining in population since 2020, but it grew slightly between 2010 and 2020. Our second largest also grew slightly, Cook County. Harris County grew a bit faster than the previous two counties. So this gives you a little bit of a sense of how that plays out. Now, eyeballing it like this as an analytic strategy is not necessarily what you want to do. You want to make a calculation so you can say and confidently answer the question, what are the fastest growing and the slowest growing counties in the country? So let's do some analysis to get that done. What we're going to do is use the mutate function to calculate a total change column. That's just going to be your value 20 minus your value 10. And then a percent change, where we take the total change divided by the value 10 column and multiply that by 100. That'll give us a sense of the percent change between those two decennial census enumerations. So let's compute that. I'm going to jump back here to my code. I'm going to run my county change. We can take a quick peek and we see that this is what our data is going to look like. If I pop that open here, we can do some browsing. So let's see which county in the United States, and you could potentially use your arrange or your filter commands like you learned earlier in this workshop, but let's just do some interactive browsing in our studio. Let's sort the total change. Who lost the most? Well, it was San Juan, Puerto Rico. Makes a lot of sense. We had certainly Hurricane Maria during this period, which severely affected much of the island. Baltimore City, so mainland US, Baltimore City lost the most people, losing 35,253. Wayne County, which is Detroit, also lost a lot of people, 27,023. Though we notice the percentage changes are somewhat different. So we want to look at that. The counties that gain the most, well, there you go. Harris County, Texas, which is Houston, added nearly 640,000 people between 2010 and 2020, which is a number larger than most counties. Maricopa County, Arizona, which is Phoenix, added over 600,000. King County, Washington, Seattle, came in number 3. Clark County, Nevada, came in number 4. That's Las Vegas. And hey, Tarrant County, Texas, Fort Worth, that's my home county. We added 1,606. I was one of those people. I moved to Tarrant County between 2010 and 2020. So I'm included in that statistic. And so what we have here is some data, but these are only really big counties. It doesn't give us a sense of relative change. So you might have a smaller county that grew a lot or lost a lot of people, but that's not going to get necessarily captured because these are all very large urban counties. So if I sort on percent change, Alexander County, Illinois comes in with the greatest decline. And that's going to be a 36% drop in its population. Schleicher County, Texas comes in second, losing 29% of its population. You can see these are smaller, likely rural counties. So the narrative of people flocking to Texas is true, but it's largely to urban Texas. Whereas a lot of these rural Texas counties you can see here are actually losing population. You have to be careful about this, though. We look at Loving County, Texas, with a 22% drop in its population, but that only reflected 18 people because it is, by population in 2020, the smallest in the country. In terms of percent growth, well, the portrait gets a little bit different. McKenzie County and Williams County, North Dakota, showing by far the greatest percentage change. Well, that's up there in the Bakken Shale, where we saw an oil boom during this period in North Dakota, and a lot of people moving there, some permanently, some as temporary workers in the oil and gas industry. You got some other suburban counties there: Colma County, Texas, Bryan County, Georgia, Osceola County, Florida, to be sure, Williamson County, Texas, just outside of Austin. You have percent changes above 40%. So pretty interesting to take a look at. From there, if you want to do additional analytics on it, you might be interested in, using any of the tools that we looked at before. But you have to hold up because I have some caveats for you. We mentioned at the census tract level, so small area analysis, census tract boundaries change. You can't do a clean tract over tract analysis like I've shown you here. That's going to require specialized methods. We will cover that in a couple weeks. But even at the county or county equivalent level, you're going to run into some problems. County names and boundaries can change from year to year, and this can cause some problems in your time series. Most counties don't change, but they can. And I want to show you an example of how this works. So if we were to take a look at in our county change data set, what are those counties that don't have a value for 2010? Well, let's take a look at it. There are 4, 3 of which are in Alaska. So Alaska frequently redraws its census boundaries. Alaska doesn't have counties, but it'll tabulate for places like Anchorage and Fairbanks, the cities, and then it has a bunch of, then it'll have boroughs that it tabulates for, and it'll also have what we call census areas. And these are going to be rural parts of Alaska, very remote parts of Alaska that are considered kind of census tabulation areas. And Alaska reorganizes this all the time. And so you'll see that if you're trying to do time series in Alaska, from census to census, you're likely going to have at the county level or the county equivalent level different geographies. We also see Oglala Lakota County in South Dakota. And Oglala Lakota County wasn't a redrawing of a county, but it was a renaming of a county. So it was formerly known as Shannon County in South Dakota. It was renamed this is a heavily Native American area to reflect the population of the location. That said, even though the county boundary didn't change, because the name changed, whenever a name change happens, census gives you or creates a new GeoID, which means that you would need to go back and handle that to standardize it. You might say, well, can Tidy Census do that for me? I'm not going to do that because there are all sorts of different use cases that you need to be aware of. In some cases, the county boundaries don't change, but the name does change. In some cases, the boundaries and the name change. For example, and this is something that I mentioned briefly last time, Connecticut redrew all of its county equivalent boundaries as of the 2022 ACS. So it doesn't show up in the 2020 census, but it will for 2030. So for Connecticut, everything is different moving forward. So those are some little tips. One other thing that I did want to mention before I leave you, and I'll spend a little bit of time answering questions, is, something that, and I see that Chuck just answered a very germane question. Has the Census Bureau thought about a promise to change the endpoints for the API to include pre-2000 data? So when I first wrote Tidy Census, the 1990 data were available on the API. They took that down. I would not expect Census to add anything prior to 2000. Given that the 1990 used to be available, they took that down. And so Chuck says, should we rely on NHGIS? The answer is yes. So NHGIS is a fantastic project out of the University of Minnesota, which was my graduate alma mater. And so I'm very fond of the project and know a lot of great people who continue to work on that project. And it's particularly germane for all of you, as if you've been following me at all on social media or you attended the last webinar, you know that we had a 2-day blip in which a lot of data sets were not available last week. And so NHGIS is likely to be a stable solution for you. And so I'm going to jump over to that website and just kind of talk you through how you want to get started. And so you'll need to register for NHGIS to use it. And if you click register here, you'll fill out this form, you'll let them know how you're going to use it, and then you will agree to their terms of use. But once you have registered, you're going to get access to their incredible repository of data. And so they have all of the American Community Survey, all of the decennial census data, and importantly, they go back, if you click here, years, all the way back to 1790. Now, the United States was not fully tracted until, I believe, 1990. And so if you're doing tract level analysis, you're not necessarily going to be able to do that all the way back. But we had census tracts for large cities going back 100 plus years. And from a census data standpoint, again, you can go all the way back to 1790 and then even find data sets for non-decennial years as available. And so there is so much data to explore. And in the event of census data outages in the future, which if that does happen and you need to keep your work going, check out NHGIS. It is a free resource. It is fantastic. You can download tables of data. You can download all of the geographic data files as well to merge for mapping. And so you can go through and look at the data sets that are available. There are tons. And it allows you to filter by different series types. So decennial census, you can see here, you've got all of our different data files, the detailed data files from DHC, the ACS, you've got all of those different data files. You can even look at agriculture censuses going way back, special supplemental files, even 100% count detailed data. It's pretty great stuff. And so I would strongly encourage you to check that out. And at the very least, hop over there, grab an account, um, and try playing around with the data to get started because that's something that, again, if we do have any other blips or data outages, that's going to be a stable solution. So, and notice, I noticed in the Q&A there, Zeke put in the link. I'm going to pop that into the chat as well. NHGIS. All right. Well, we're up against time. So 200 of you stuck around the entire 3 hours, which I really, really appreciate. Again, I know how busy you are. I know how much you have on your plates. And I just feel very grateful to you and to SS Dan for giving me the platform where I can share some of these materials with you. Again, I'm going to hand it back over to Bill to close things out, but I hope to see many of you back here in 2 weeks because I'm pretty excited about that next webinar because I love mapping and I love spatial data.